Question 7. Find algebraically the exact solutions to the equation 2x times e to the power 3x plus 1 equals 10. So my key part of the question is the actual equation, and the bit that's telling me how it wants the answer is it wants it algebraically. So that means it wants me to do algebra, and it wants exact solutions. So that means not rounding my decimal at the end, so avoiding decimals. So using ln's, using pi's, using e's, stuff like that. Okay, so it might not be obvious straight away how we tackle questions like this. However, our key knowledge should be that if we have our unknown as a power, so the x is a power, that means we're going to use logs. So the rule for logs is if I have something like a to the power x equals b, to solve that I would do x equals log base a of b. And if we have a special number, remember e is a really special number, so instead of writing log e, we write that as a log e of a number. So say let's say log e of b, we write that as ln b. Okay, so there's multiple ways of solving this. So I'm going to show you the two main ways. I think I showed you these in lessons as well, so you'll be familiar with them. So method 1 is, as we have our powers as our unknowns and there's times, there's two things timed together, using ln's is going to help. So method 1 is the ln method. So we're going to take ln's of both sides. So we're going to apply ln to both sides. I'm going to write the times symbol in the middle to be really explicit. So ln of both sides. Okay, I need some more key knowledge. So I need to know that for logs, if I have log any base a plus log any base b, then if I'm adding them, I can times my numbers. So log of a plus log of b with any bases is equal to log of that base a b, as long as the bases are the same. So they have to be the same base. Let's call them c. So if I think of ln as a log base e, I can use that rule because I've got a times there. So I can rewrite that as ln 2x plus ln e to the 3x plus 1 equals ln 10. I've got another key knowledge. If I've got log any base again of a number, so it's called a to the power of a number, so it's the n, then what I'm allowed to do is I'm allowed to put the power at the front, so times by the power. So log base c of a, like that. So I can use that rule because I've got power x, I can put that at the front, so x ln 2 plus I've got the power 3x plus 1 times ln e equals ln 10. Okay, some more key knowledge. ln e, the inverses, so they cancel out, so I get the number 1. You're checking your calculator if you don't believe me, but e to the power 1 is e, so therefore ln e must equal 1. So this thing here is just 1. So I've got x ln 2 plus 3x plus 1 times 1 just gives me 3x plus 1, so I don't need the brackets anymore, equals ln 10. And to solve that, we're just going to do algebra. But before I do the algebra, I'm going to go on to method 2 to get to the same step. So method 2, this is the one where we change our bases. So I know some of us preferred this method, dealing with the same base, because then we can deal with stuff easily. And the formula was any number to the power x is the same thing as e to the power of that number, but I need times the power by ln of my base a. Yeah, and that works for any base. So if I use that here for the 2 to the power x, I get e to the power x, but I need times the power by ln2 times e to the power 3x plus 1 must equal 10. So now some more key knowledge. Now this time it comes from GCSE. If I've got a to the power x times a to the power y, we add the powers. And in fact, that's kind of, well, that is actually where the log rule comes from over here. So instead of using a log rule, I'm using a power rule. So I add my powers. So e to the power x ln2 plus 3x plus 1 must equal 10. Okay, that's good now, because I've got one base to the power of something equals a number. So I can now use my key knowledge from the first line, where to get rid of a base, I do log. So to get rid of base e, I'm going to do ln. I'm going to take ln, so I get the power equals ln 10. And now I'm at the same step as the other method. So I don't have to do the last few steps twice. Okay, so now it's just down to algebra. So our technique here is we want to get x's all on one side. So I'm going to have x ln2 can stay, plus 3x can stay, but I'm going to subtract the 1 from both sides. So I'm going to put minus 1 plus ln 10. And remember, I'm really fussy. I like to have my negatives, or my numbers, in fact, before the ln's. I can then factorize out an x. So I'll get ln2 plus 3, which is annoying me. I want to have the 3 at the front. So in fact, I'm going to change that now. 3 plus ln2 equals minus 1 plus ln 10, and then just divide by the factor. So minus 1 plus ln 10 divided by 3 plus ln 2. And that's our final answer. You can always use your calculator to check using solven and check that the decimals match. So now talking through where the marks come from. Okay, so obviously there's different ways of doing this. So by taking ln's and splitting it up into an add gets you a first mark. By bringing the powers to the front gets you a second mark. By spotting ln e is 1 gets you a third mark. By factorizing out your x gets you your fourth mark, and again, obviously the right answer gets you the last mark. So the first mark, let's just repeat that again, is doing ln's of both sides, taking ln's and splitting it up into an add. So by getting the second line I've written there. The second one was by putting the powers at the front. Now you should have brackets around 3x plus 1, but since this is a method mark, we'll let you off of that. For then spotting ln e is 1, gets you a third mark. And then factorizing out an x. So at this point here, you might have made slightly some mistakes with maybe signs, but you still get a mark for factorizing out your x. And then dividing by it gets you the final mark. If you use the other method, this one's trickier because I haven't got the mark scheme for that one, but I'll talk you through where you normally get the marks from. You normally get a mark for changing into e's. So I'm just going to draw a line so you can see the separate method. You then normally get a mark for adding the powers, and then for getting rid of the e by taking logs of both sides. And then the last two marks are the same.